start the class. Let's follow up. It is June 2022. Paper is 21. And I start with the first question. Question number 1. Define velocity. What is velocity? Velocity is the rate of change of displacement. This in between, keep me telling the answers, and we can discuss theory orally. And if needed, we can write down the definition if needed. So, what is the definition? What is the definition for velocity? Velocity is the rate of change of displacement. A rock of mass 7.5 kg is projected vertically upward from the surface of a planet. The rock leaves the surface of the planet with a speed of 4 meters per second at time t0. The variation with time of the velocity of the rock is shown. Assume that the planet does not have an atmosphere and the viscous force acting on the rock is always 0. So it means there is no air resistance there. Determine the height of the rock above the surface of the planet at t is equal to 4. So graph ko read kar le and see what is the case. It's a velocity time graph. If velocity time graph is given, the height or distance will be found by the area under the triangle, area under the graph. So this paper threshold is 41 out of 60. So first part is simply rate of change of displacement. And now we have a graph, so we can make a triangle. Area is equal to, there are two triangles, and we need to find the area till 4. So we can find the area, and we can find the area above x-axis and area below x-axis. Why we are subtracting it? Anyone can answer why we are subtracting it?
Say because part of it is under the graph?
Because it's a case of U-turn, because height is a displacement. Height is a displacement. So if height is considered here, height is a displacement. And displacement is always found by the difference of the two area. One area is above x-axis and second area is below x-axis. I have written the rule also. Then simplify this question and see what answer comes out. It's a case of area above x-axis and area below x-axis. So please look at the figure and get the answer for me. I'm getting 3.20.
I'm also getting 3.2.
Good.
Yes, sir.
Determine the change in the momentum of the rock from time t is equal to 0 to time t is equal to 4. Is it right that change in momentum is actually impulse? Change in momentum is impulse, right? He's talking about 0 till 4. So on the 0 position, I can read the velocity at 0, and then I can read the velocity at 4. This is the velocity coming at 4. And the formula, what is the formula of impulse? Delta P is equal to mv minus u. So you have to solve it now. At 0, the velocity is here. No, he says 0 till 4, right? So at 0, velocity is coming to be 4. And at 4-second velocity is coming, is it minus 2.4? Please answer, Zain, and please you can answer. Minus 2.4 is looking to be. And then apply the formula. Let me know after applying the formula.
Will it be 48?
48. Okay, Zain, your answer?
I'm a bit slow. Just 1 second. So sorry.
I'm getting minus 48.
So I'm also getting 48, but plus 48.
And remember this concept that change in momentum this is change in momentum. Change in momentum is actually impulse. Determine the weight of the rock on this planet. Weight of the rock on this planet, W is equal to mg. How I can get the g on this planet? G is the acceleration. So do you think that g will be the gradient of this line? G is the acceleration. And if it's a velocity time graph, the gradient will be acceleration. So for a velocity time graph, gradient is the acceleration. So now find the gradient. So one option is there. Okay, find the gradient. If we can find that somehow, take 2 points because I think we can take this point and this point. 1 point will be 4 comma minus 2.4 and the other point will be 0 comma 4. Now find the gradient. It's a straight line which looks to be a constant gradient. Let me know if you get the answer. Second approach is this, that you can use F is equal to impulse upon time. As the object is moving on the planet and there is no other force, no viscous drag, then we can get it from this position. F is equal to delta P upon T, impulse upon time, and we can use this for our calculation.
But then why don't we use minus 48?
Minus?
48, like it's minus, right? So then why isn't it
But
there?
definitely minus 48 is not the case, because minus was only for impulse. It's a rule in impulse that impulse can be minus or plus, because when object is moving in a system and there are other system or other object also, one impulse is always plus and second is also minus. So impulse case, in impulse case, we can neglect the minus in any calculation. It is not momentum, it is impulse. So impulse, in case of impulse, we can consider that. Now, in practice, the planet in B does not have an atmosphere that causes a viscous force to act on the moving rock. State and explain the variation, if any, in the resultant force on the rock as it moves down. There is no viscous, if the viscous drag is there. So what is the theory? It's a famous theory. If viscous drag is present, viscous drag will increase, the resultant force will decrease, and the object may reach terminal velocity. So what is that theory? If we recall our important famous theory, it is thrown upward. This is the object and this is the weight. This might be the driving force. Let's say it is the driving force. Object is going upward. If object is going upward, the viscous drag is also, viscous drag will be downward, because viscous drag always opposes the motion. As the object is going upward, the weight is constant, but the viscous drag will increase. B will increase as velocity, if it increases, viscous drag, the resultant force decreases. Now this is the working. So you can copy this working. state what is meant by the center of gravity of an object. It is the point at which the weight of an object is said to act, is assumed to act. A non-uniform rod, it's a non-uniform rod. That's why the object may have a displaced center of gravity. A non-uniform rod XY is pivoted at point P as shown. The rod has length 4 meter and weight 44 Newton. The center of gravity of the rod is 1.70 meter from end X of the rod. Point P is 1.10 from end X. A sphere hangs by a wire from end Y of the rod. The weight of the sphere is 3 Newton. The weight of the wire is negligible. A force F is applied vertically downward at end X so that the horizontal rod is in equilibrium. In equilibrium means clockwise moment is equal to anti-clockwise moment. Equilibrium means clockwise moment is equal to anti-clockwise moment. By taking moment, if a force F is applied vertically downward and at angle X, so that the horizontal rod is in equilibrium. By taking moment about P, calculate F. By taking moments about P. So now start solving this. The system is in equilibrium. Every distance has to be taken from the pivot. Now, help me to make the equation and find the answer. What equation should I use?
Moments equal to force time displacement or distance.
So can you scroll down a bit?
Yes, then what did you say? Check the answer. I'm getting 32. Check the working.
Yes, sir. Also, it's matching. 12:35.
I'm also getting 32.
Yes, please repeat what answer you're getting.
32.
32. What about Zen? What answer you're getting?
Sir, I told you 31.95 to 32.
Hmm. Calculate the force exerted on the rod by the pivot. On the rod by the pivot. So if I draw a force here, this one. So this is the force, let's say it's X. How we can find this force? We already have find by taking moment about P. We have taken moment about P.
So we just add all the forces 32, 44, and 3.
Because the rule is there, the sum of total upward force is equal to total downward force. So I take F, I take 44, I take 3. So if I connect them and I add them, this is total downward. Total downward is equal to total upward. So you have to add all of them and equal to X. Check the working and get the answer. The sphere in B is now immersed in a liquid in a container as shown. When they immerse it in a liquid, the object will experience an upthrust like this. Its weight will be still downward, but now it will experience an upthrust. The density of the liquid is 1100. The upthrust acting on the sphere due to the liquid is 2.5. The magnitude of F is unchanged so that the horizontal rod is not in equilibrium. Use Archimedes principle to determine the radius of the sphere. So apply the formula for upthrust. U is equal to rho Vg. Upthrust has a formula. U is equal to, as it is a sphere, so you can use 4 upon 3 pi r cube into g. Now you should rearrange the formula. You should rearrange the formula. And then in order to find the value of r, you have to take the cube root. Now solve it and find the answer.
I'm getting 0.038.
Okay, 0. 0.038.
Yes, sir. So I was in a slightly different one, but there was a mistake in my calculation. I'm saying.
But you have followed the derivation, right?
Yes, sir. वो calculation पे, वो calculator पे I had punched a number wrong.
Calculate the magnitude and direction of the resultant moment of the forces on the rod about P. When you use the word resultant, it is possible because the examiner has given us the hint that the rod is not in equilibrium. So when it is not in equilibrium, it must be rotating. Resultant moments in the same direction are added and moment in the opposite direction are subtracted. Now, here we have to see that if this is the pivot, this will be anti-clockwise, this will be clockwise, and this will be clockwise. So I should add up the clockwise moment and subtract the anti-clockwise from it. Moments in the same direction are added and moments in opposite direction are subtracted. Let me know the answer. The resultant moment.
So is it 7.3?
Moments in the same direction are added and opposite direction are subtracted. Zen, what are you getting?
So the same answer. I added the
Okay, now define power. Power is the rate of doing work. A force takes time t to move an object through a displacement x at constant velocity. This is a very well-known derivation, and you can always start it from the formula. Power is equal to work upon time. Power is equal to work upon time. Power is equal to Fd upon T. Power is equal to F into D upon T. So power is equal to displacement upon time is velocity. So this is a small derivation, and this is the formula. You have to copy this derivation. A block is pulled up a slope by a wire attached to a motor as shown. The useful power output of the motor is 56 watt. The block has a weight of 430 Newton and travels with constant velocity along the slope at an angle of 11 degree. Assume there are no resistive forces opposing the motion of the block. Calculate the tension in the string. So let's think about resolving the forces, and I have shown the weight. So now resolve the forces and get the answer for me.
It'll be 430 sine 11, which will be 82 Newton.
So you got in that way. The main thing is the resolution. So if I resolve it, I will get the angle 11 here. Now I have resolved the forces. He says velocity is constant, weight is given 430 Newton. As the weight is given, I can use directly W. Then solve it. Tension is upward. Object is moving at a constant velocity. V is there. There is no acceleration. So you can equate the forces. You can say T is equal to W sine theta. E is equal to 430 sine 11. Make sure the calculator is in degree mode. See what answer is coming here. If you calculate the tension,
82.
82. 82.
Yeah.
Is it a rounded answer?
I got 82.0, so I just wrote 82.
Okay. Then what are you getting?
Just calculating it.
Are you solving with us? Yeah, you have
Yes,
just
yes,
like
yes. Fine.
speed of the block. The block is going upward. The tension is pulling the object. So if it is pulling it upward, tension will be equal to power upon velocity. I have used the logic. Upward force is P upon V and downward force is W sine 11. The power is given to be 56.
It will be 0.68.
0.68.
0.68. the rate of increase of gravitational potential energy of the block is equal to the useful power output of the motor. One of the reasons for is this that there is no work done against resistive forces by considering the motion of the block state. Another reason for this, he says the motor delivery is the same as the increase in gravitational potential energy, and the reason is that there is no work done against resistive force. Second point is that velocity is constant. When velocity is constant, nothing is going for kinetic energy. Normally, what equation comes when something is going up on a slope? When something is going up on a slope, there is a work done against resistance. Work is done to increase kinetic energy. Work is done to increase potential energy. But there is no change in kinetic energy because the speed is constant. So there is no share of that. The motor has an efficiency of 80%. The time taken for an input energy of 1.2 kilojoule to be supplied to the motor. Now see how we do part number 4. So I have a power of 80% and I want to know the time taken for an input energy. The input power of the motor is 56. Now solve this. First find the output power. First find the output power and then put it back and find the time.
Is the output power 44.8?
Then very low sound. I can't hear.
Sir, is the output power 44.8?
Okay, I don't know. 44.8 looks fine to me.
$26.78 will be the time.
Yeah, but now the sound is very loud and a bit bubbly.
1 second.
Something think you have some type of just like it sounds like underwater sound.
Is this better?
How it's better now? Can you find the time?
So 26.78. 26.78.
7-8.
G.
A spring is suspended from a fixed point at, yes, what are you getting after?
Sir, the previous question, the marking scheme has a different answer.
Oh,
It's 17.
17.
I must have made some mistake with the calculation.
What working they have done?
Or did
So now check the answer. Let me know the answer.
it's 17. 16.9. So basically 17.
A spring is suspended from a fixed point at one end and a vertical force is applied to the other end. The variation of the applied force with the length of the spring is shown. Determine the spring constant. So we can find the gradient because actually it is not an extension graph, but if we draw an extension graph, it will be having the same gradient. Now solve this gradient quickly.
$75.
75. Let's calculate the answer and then move forward. First, check the answer. Determine the elastic potential energy when the applied force is 15. So how we do this question? Applied, should we go for the area?
Yeah, we can use area like half of fx.
Or we use the formula half kx square?
We can use half fx too, right?
Because we have the spring constant. Actually, the graph he has drawn is not the extension graph. So we cannot directly find out, we cannot directly find out the area until we shift the graph. So we can, if we use the area, we have to assume that the same graph is formed behind that part. So we can find this area, or we can use half fx, half fx or half kx square. So look at this working.
I'm getting the same answer.
Question number 5, a horizontal string is a stretch between two fixed points A and B. A vibrator is used to oscillate the string and produce an observable stationary wave. At one instant, the moving string is straight as shown. The dots in the diagram represent the position of node on the string. The point P on the string is moving downward. The point P, so these are the nodes. The waves on the string has a speed of 35 and a period of 0.04. How the stationary wave is formed on the string. This we discuss in our regular class also, that a stationary wave is produced when the incident and the reflected, progressive waves superimpose on each other. Their superposition generates a stationary wave. Sketch a line to show a possible position of the string a quarter of a cycle later than the position shown in the diagram. Remember, in a stationary waves, nodes are fixed. Antinodes are also fixed. You have to draw the wave after a quarter of a cycle later than the position shown. So this will be the wave. After that, determine the horizontal distance from A to B. This is the concept which comes very oftenly. A to B, you have to count the number of nodes, and then you have to see 1, 2, 3, 4, 5. There are 5 gaps, so it will be 5 lambda by 2. It is 5 lambda upon 2. So you put the thing, so lambda is equal to 2d upon 5. Make the subject and put the values to find the value of d. Look at this working, solve it and get the answer. A particle on the string has zero displacement at time 0. From 0 till time 0.06 second, the particle moves through a total distance of 72 millimeter. Calculate the amplitude of oscillation. Now, how we do such a question? We know that particle will be moving up and down, and the total distance particle has traveled is 72. Now, from 0 till 0.06. What is the time period? Look at the time period is 0.04. Time period is 0.04. So if I make a diagram in my memory, in my working, the particle goes up, particle comes down. So it is 0.02. It is 0.02. So the cycle will be 0.04, but we have to cover 0.06. So it will make another cycle. It will go up once again. So another 0.02. This is how the motion is there. The particle will actually 2.5. So now what is the amplitude? He says the particle moves through a total distance of 72 millimeter. I know the time period, I know the difference, but how I can find the amplitude? So we have this displacement and it goes up, comes down, and we know the time period. So we use it in a ratio and then we find we have 72 millimeter is the total. So it's a 1, 2, 3, 4, 5, 6. So it's 6 times the amplitude. And then we divide it by 6 to get the amplitude. Look at this working.
Wait, how did we get 6 times displacement?
Because if you go up, then comes down. Look, this is one amplitude, second amplitude, third amplitude, fourth amplitude, fifth amplitude, and sixth amplitude. Amplitude is the distance from the mean position. And he says that we know that 0.04 is one cycle. 0.04 is the one cycle, and then it is 0.06. So in a time of 0.06, it will travel 6 amplitudes. So you will divide the 72 millimeter by 6. State Kirchhoff first law. Total currents entering a junction is always equal to total current leaving the junction. A battery is connected to two resistors X and Y as shown. The resistance of resistor X is greater than the resistor of resistor Y. State in which resistor dissipates more power. Greater the resistance, greater the power. So you will tell the examiner that resistance X is greater than resistance Y. It's a parallel circuit. Greater the resistance, smaller is the current. Look at this conceptual working. Power is equal to V square upon R. The two resistors are made of wires that have the same length. Both wires are made from metal of the same resistivity. Still an explain which resistor is made of wire with a larger cross-sectional area. He has already mentioned that resistance of resistance X is greater than resistance of resistor Y. And you know that R, what's the concept? R is proportional to cross-sectional area. R is inversely proportional to cross-sectional area. So it's simple that R is inversely proportional to area. So where you want to increase the resistance, you have to use thinner, you have to increase the resistance, you have to use thin wire. A battery of a EMF 9 volt and negligible internal resistance is connected in series with an LDR and a fixed resistor of resistance 1800 ohm as shown. Now he has connected an LDR and we have to see the working that he says the voltmeter is connected across the fixed resistor. Calculate the current in the circuit. The formula is I is equal to V upon R. Now, we have the resistance, and if you see the question from here, the resistance is 1800 ohm. The battery is 9 volt. So, how we know the resistance on voltage voltmeter reading is 5.5, 5.4. So, we can put the formula I is equal to V upon R and solve it. In the second part, the logic is there. If this is 9 volt and it is this first resistor is getting 5.4, Then how we get the voltage across it? 9 minus 5.4. This is the logic of series combination. Calculate the resistance. So resistance of the LDR, R is equal to V upon I. I have subtracted it and get the value. The intensity of light eliminating the LDR increases. So bright light comes on it. By reference to the current in the circuit, state and explain the change, if any, to the voltmeter reading. So when what happened when the light intensity is more. So you know that when light is brighter, resistance of LDR decreases. When resistance of LDR decreases, the voltage across LDR will decrease and voltage across 1800 ohm resistor will increase. An unstable nucleus decays by emitting a beta minus particle. Determine quantitatively the changes, if any, in A and Z. We know that during a beta minus decay, mass number remains the same and atomic number increases by 1. In addition to the beta minus, another lepton is emitted during the decay. What's the name of that? Anti-neutrino, anti-electron neutrino. The particle P is composed of an up quark and a down quark. Calculate the charge Q of particle P. This is a memory because you have to remember that the particle consists of an up quark and a down quark. So you remember that table which I shared, and you put that U is equal to 1 upon 3E and D is equal to 2 upon 3E. Particle P belongs to two classes. Name of these two classes, baryon and meson. How we know it's baryon and meson? Because we remember the number, because we combine them, we are getting 1E. And you know 1E means proton. So it should be a baryon. The second is meson. Both are part of hadrons. So this is the end of the paper, and we will inshallah continue in our next class. Allah Hafiz.
Officer.